So, guys, like I was saying, welcome. We'll be looking at a few. It's sort of an autopsy after the test. We'll be looking at a few problems from the test that some people mentioned might have been a bit difficult. We did a few yesterday, but then the more challenging ones, we sort of left them um, for you guys to attempt as well. But we'll go through the ones that we didn't do yesterday today, right? So, and then maybe if you guys have any questions, we can just go back to whatever we did yesterday, right? So looking at the first question here, which I think was a bit difficult. We have that the second derivative of f of x minus the first derivative of f of x minus 2 times f of x is equal to 0. And we're given that the first derivative at 0 of f of x is equal to minus 2, as well as the value of f of x at 0 is equal to 2, right? And we are asked to find what's the value of f of 1. So now one of the ways you can go about solving this, right? So just ignore this. One of the ways you can go about solving this is by letting, right? What I will say here is, for example, we can, right? We can let f of x, right, which is the function we're trying to find, let f of x be some function e to the ax, okay? And now let's take the first derivative of that and see what we find, right? So when you look for f prime of x, what you get is what do you get? Can anyone give me the answer here?
E to the a of x.
Yes, but sorry, go ahead.
Do you want the derivative of that function?
Yes.
Is it not e to the a of x times a to the x? No, a.
So yes, so it's e to the a of x multiplied by a. So we can just put the a in the front here.
Wait,
Right?
so I have a question. Why did you choose
Yeah.
that function specifically? Could you choose any or what?
Okay, so the reason why I chose this, so it's not a straightforward thing to see, but the reason why I chose it is in the options that you were given, right? If you go back to your test, right? In the options that you were given as the answers, you had some functions that had e to the something, right? So for the sake of solving this problem, I chose e to the a of x as the function that we represent here. Okay.
Okay, thank you.
But yeah, so it's not a straightforward thing, but you sort of have to look at the options that are given and you see sort of like the common function that is there. So that's why I chose the e to the a of x, right? So now when you take the second derivative of e to the a of x, right, you should find, can anyone tell me? Right, so you should find a squared multiplied by, sorry, go ahead.
I already got the answer. I was want to ask that question.
Yeah. Sorry, which question? Oh, you already got the answer.
Yeah, for the second derivative, yes.
Okay, yeah, okay. Thank you.
Yeah.
Right. So now you plug this into the equation that is given, right? So if we go back to our original equation, the second derivative is equal to a squared times e to the ax. So let's plug in there. The first derivative is equal to a to the a multiplied by e to the a of x. Let's plug that in there. And the function that we chose was e to the a of x. Right. Okay, so now you can clearly see that e to the a of x is a common factor between these three terms, right? So the way you do it is you take out the e to the a of x as it is a common factor. So let's just take it out and then open a bracket. In the bracket, you would have a squared minus a minus 2, right? All multiplied by e to the a of x, right? Now, here, we want to solve this, this quadratic equation here, right? So let's solve. This factor can only be equal to 0 if either e to the a of x is equal to 0 or a times a squared minus a minus 2 is equal to 0, right? So now we know that e to the a of x will not be equal to 0 in our case. The reason why is because we are sticking to values like 0 and 1, right? Which should not give us 0. Okay, whatever the value of a, because a is a constant number, right? It can be anything, but we know that x is staying somewhere between 0 and 1 based on the question that we're given here. We're not asked to find the value of the function as x tends to infinity, so we're not going to those very high values like infinity, right? So we're sticking to very small values, so we can tell for sure that e to the a of x will never be equal to 0, right? So the only real thing that we can say can't be equal to 0 is a squared minus a minus 2. So that's what we have to solve, right? So we have to solve this quadratic equation, right? So now if you solve this quadratic equation quickly, give me the two values that a can have for this equation to be satisfied. So what's the first value of a?
Positive 1 and negative 2.
So negative 1, sorry, can you repeat that?
So a can be equal to 1 and negative 2. Yeah.
2 and negative 1.
2 and negative 1, yes, that's correct. Because if you say 1, what happens when you plug in 1 here? You have 1 squared, which is 1, minus 1, which is 0, minus 2. So you have minus 2, which is not equal to 0. So a must
Okay.
So a must be equal to minus 1 or a must be equal to 2, right? So we have the two values that a can have. So now we can go back to our original function, right? And the way we express this, because since we have two solutions, right? The way you you express the solutions to the to what the value of f of x can be, you say that f of x can be equal to some constant a, right, that we don't know but will determine, multiplied by e to the first value of a, which is what? Which is minus 1. So multiplied by e to the minus x, right? That's the first value of a plus some constant b, right? Multiplied by e to the 2x, because the second value of a is 2, right? So this is sort of like the general form that the function f of x has to have, right? If you had three roots, so if you had like a cubic equation that would have 3 roots, then you would have 3 terms. So you would add another term plus c multiplied by e to whatever that third root is. Okay, so this is the general form that f of x has to have. But now we are given already, right? So one of the things that we're given is that we are given that f of 0, right, is equal to 2, right? So what that means is if you substitute 2 into this one, if you substitute 0 into that expression, so let's do that. A, right, times e to the minus 0, which is just e to the 0, right? That's b times e to the 0 as well, right? And then you have, so basically a plus b should be equal, let me put that in uppercase, should be equal to 2, right? Based on what we're given in the problem. But we are also given that, right? We are also given that f prime of f of x at 0 is equal to what? It's equal to minus 2, right? So when you substitute, so you can easily take the let's first find what's f prime of x. What's the derivative of this expression? Right? So f prime is basically equal to what? Can you guys tell me? You're deriving this expression here. A and B are constants.
So it has to be minus xae to the power of minus x minus 1 plus 2xbe to the power of 2x minus 1.
Okay, so it has to be, remember, it can't be minus x because remember you are, a is a constant, so you are only deriving e to the minus x, for example. So you write back the expression, right? Because it's an exponent, you write back the expression a e to the minus x, and then you just derive the exponent. What's the derivative of minus x? That's minus 1, okay? So you need to be careful with the sign. It's not minus x, it's minus 1 because you're taking the derivative of the exponent. You're not just rewriting the exponent. So just pay attention to that for the next problem. Okay, so same thing applies for the second one. You take the derivative of the exponent, which is just 2, multiplied by b, which is a constant, multiplied by the original exponent function. So that is what the derivative of f of x is, right? So now if you substitute the value of 0 into this derivative, what do you get? Well, you get, again, minus a, right? Times e to the minus 0, which is just e to the 0, which is 1. So minus a plus 2b times e to the 0, which is just 2b. Okay, right? 2b. And that is telling you that it's equal to minus 2, right? So now you have two equations with unknowns, right? With two unknowns. So a and b are the values that you're trying to find. So you have a plus b is equal to 2, but you also have minus a plus 2b is equal to minus 2, right? So now, what should be the two values of a and b if you solve those two equations? I'll let you guys solve it and give me the two values that you should be expecting for a and b. So I'll just give you a few minutes. Figure out what the two values of a and b should be, and then tell me.
I have b is equal to 0 and a is equal to 2.
So b is equal to 0 and a is equal to 2. Let me just write it down. Does everyone agree?
B is equal to 0 and A is equal to 2.
Oh, okay, sorry. B is equal to 0 and A is equal to 2. Okay. Does everyone agree there?
I thought B is equal to 4 or 3.
Sorry? Two equations, guys. These are two equations with two unknowns. A plus B is equal to 2. Minus A plus 2B is equal to minus 2. Your question, your answer, what you're trying to do is you're trying to find the value of A and B. Right? So I need one more person who can confirm this result. If it's true, then it's true. If it's not, then just give whatever your solution is, and then we can discuss.
Yes, it's true.
So it's true.
Yes.
Right. So everyone else, please attempt it again. If you did get the same answer, good for you. If you didn't, just try again, and then you should be able to get these answers. So these are the two values that we find, right? So what that means is our function f of x, which is what we are trying to find this whole time, right, is now equal to a function f of x is equal to what's the value of a? The value of a is 2, so 2 times e to the minus x, right, plus 0, okay, which is, we'll just leave it like that, because b is equal to 0, okay, so whatever this factor is, it's equal to 0. So this is the function that we have. That's what f of x should be, okay? So now that we found f of x, all we can do is we substitute the value of of 1 into that, right? And we see what we get. So therefore, f of 1 is equal to what? Is equal to 2 times e to the minus 1, right? Which should be one of the options that is given in the test, okay? So there you go. Any questions here?
In a normal test, Jonathan, how many marks do you think this question will be allocated? Because for that test, I think it was 4.
Okay, so the reason why it was 4 for this particular test, or at least that's what I think, it's because you really had to like go through all of this, but that's on your like or your paper on the side. All they need to have is the
On the
final
side.
answer.
Oh, yeah.
Right? Because it's a multiple choice question in the test. So all you needed to do was just solve all of this on the side and then choose the correct option from what was given there.
Yes.
So I think the reason why they gave it 4 marks might be because it had to ask you to do all of this. So all of this, maybe in a normal test would be the 4 marks again, but they would have to like spread it out like 0.5, 0.5 in whatever manner they decide to do it. Okay, so that's just my opinion, but again, don't take my word for
Also, in
it
a normal
because
test, you think they would give us like a hint? Because there's not that there's no ways, but like it would take some time for someone to figure out that.
to figure out.
Let-
Yes, I think okay, so since this is on the record, I can't tell you for sure that they would give you a hint, but I think since they realized that since the test was online, they had to make it a little bit more challenging because otherwise it's straightforward, right? So they
Okay.
need to make it a little bit more challenging. Which is why you had to like figure out all of this. But in a normal exam or tests, written tests, sit-down tests, you wouldn't have to deal. I think at least it's the same lecturers so I think you wouldn't have to deal with like complicated questions such as this one. right?
Okay.
They would sort of give you a little bit more straightforward questions. Maybe you might have like one or two of these questions because to make it a little bit more difficult, but I don't think they would they would make it most of the test or most of the exam. Let me put it that way.
No problem. Thanks.
Yeah, no problem. Right. So yeah, I guess that's it. Any other questions? Okay, so moving on to the next question that we have here, which is asking us to evaluate this limits. Okay, so I was also looking at like some of the more difficult questions, and I realized that this one might have been one of them. Although we sort of did some of these types of questions in our worksheets. Okay, so in our previous worksheets. So you should have some sort of an idea on how to solve this. So if you substitute in the value of x for this limit, you will see that it's equal to e to the infinity. Okay. At this point, I think you guys can see that already, because you will have 1 plus 1 over infinity, which is 0. So 1 to the exponent of x squared, x which is infinity, so infinity multiplied by arctan of x squared, right? Which is arctan of infinity, well, which is whatever function that gives you, right? It doesn't really matter because, okay, let me just double check something. Let me just double check the question from the test. Just give me a minute, guys. Bear with me. Okay, yes. All right. So basically, it would give you 1 to the infinity, right? Which is in an indeterminate form. So what you would do is you would introduce the exponent function into this, using what you guys should remember, the fact that e to the ln of x, right, is equal to x, right? So using that, you can just then substitute the sorry, looks like I was muted. So using that, you can just substitute the value of x into this expression, and x is just in this entire thing here. You can just copy it and place it into that exponent there, and that should be equal to the same thing. Okay, so now you basically, when you're looking for the limits of the left hand side, you're basically looking for the limit of the right hand side as well, because those two limits are the same. Okay, so now let's try to find the limits of the left hand side. And for that, we just copied this and we replace it into this, right? And when you substitute in the value of x again, you will get 1 to the infinity. So you still have that problem. But remember that we can take this exponent here, x times arctan of x. We can take that out of the ln, right? So when you take it out, what you get is, let me just copy this. So this exponents would all right. So you would get that, and then this whole thing would be divided by x 1 over 1 over x squared times arc 10 of x squared. Okay. Right. And then when you substitute in the value of x again, now you would get 1, right? 1 over, sorry, just give me a minute. So you would get ln of 1 plus 1 over infinity as x tends to infinity, right? So as x tends to infinity, this ln here in the numerator would be equal to 0, okay? And then as x tends to infinity, the denominator 1 over x squared times arctan of x would be equal to 0 as well. So you would get 0 over 0, which is a case where you can apply L'Hopital's rule, right? So what I want you to do is to start deriving the numerator. So what's the derivative of ln of 1 plus 1 over x squared? So please find that derivative for me so I can just plug in the value there. I'll just give you a minute. I see a hand raised. Just unmute yourself and ask your question.
Sir, can you please repeat the step you just did?
Oh, okay. Let me just say this one here.
Oh yes, I mean like explain.
Okay. So the original question that we are given is e to the original questions that we are given is limit. We're trying to find the limit as x tends to infinity of 1 plus 1 over x squared to the x squared multiplied by arctan square x squared, right? And we said that if you substitute the value of x into this expression, you would get 1 plus 1 to the infinity, okay? Because you have 1 plus 1 over infinity, which is 0, so 1 to the x squared, which is infinity, multiplied by whatever value of arctan x squared gives you, right? So it's infinity multiplied by a constant, which just gives you infinity. So you have 1 to the infinity, which is an indeterminate form, right? This is an indeterminate form, right? And in that case, you are allowed to manipulate this expression to be able to use L'Hopital's rule, okay? And what I said was you can use the fact that e to the ln x is equal to x. Okay, just give me a second, guys. I'll be back in a few minutes. Just give me a second. Sorry about that, guys. Okay, so what you use now is the expression e to the ln x being equal to x, okay? And now, in this expression, all you do is you substitute x by our entire function here. Because remember, this expression applies for really any function in f of x. So what I should have written there is f e to the ln of f of x is just equal to f of x. Okay, f of x can be anything, can be any function, right? Can be x, it can be x squared. As long as it's a function in x, this is correct. Okay, so since this is correct, then we can just substitute f of x by our function here, which is 1 plus 1 over x squared to the x squared times arctan, which is equivalent to what we have here, our function, right? So that what I said was, if you look for the limit of the left-hand side in this equality here, the limit of the left-hand side is just equal to the limit of the right-hand side. But remember, we are trying to find the limit of the right-hand side, okay? So we can use the limit of the left-hand side as the limit of the right-hand side. So that's what we're trying to do now. We're trying to find the limit of the left-hand side, which is limits as x tends to infinity of e to the ln of our function f of x. Okay, so I hope this makes sense up to this point. But now from here, if you substitute the values again, you still get the 1 to the infinity that we had here, which is an indeterminate form. And you can't do anything with that. So you need to manipulate the expression again to be able to apply all the tricks that you have in trying to solve for the limits. So what we do is, since we have ln of 1 plus 1 over x squared to the exponent of x squared plus arctan x squared, we can take out this arctan x squared of the ln sign, and we can put it, right? So maybe this is the step that I skipped in between here. Let me just put it in there. We can take out this exponent there, right? Oh, sorry. So just give me a minute. So we can take out the exponent x squared and times arctan x squared and bring it outside the ln here. Right. Okay. So we can take it out and put it there. But another thing that we can do is remember that when you multiply two values, you can just take one. It's basically the same as multiplying one by the inverse of the dividing one by the inverse of the other one. So x squared times arctan x squared multiplied by ln of 1 plus 1 over x squared is basically the same as ln of 1 plus 1 over x squared divided by 1 over x squared times arctan x squared, okay? So I'm hoping that up to this point it makes sense. So then what you do is, when you substitute in the value of x here, you would get 0 over 0, okay? At this point now, you can apply L'Hopital's rule. So when you apply L'Hopital's rule, what do you get? What's the limit? What's the derivative of ln of 1 plus 1 over x squared?
I have open bracket 1 over 1 plus 1 over x squared.
1 plus 1 over x squared, okay?
No, 1 in the numerator divided
Okay,
by
sorry.
1 plus 1 over x squared.
Okay. Okay.
Yeah. Then times, close the brackets, times by negative 2 over x cubed.
Negative 2 over x cubed.
Yeah.
Okay. Yes. So, does everyone agree here?
Yes, I do agree.
Okay. So we can basically simplify this by taking this thing here in the numerator here, where the 1 is. So we can sort of write it down more neatly. Okay. So that's what we have in the numerator. What about the denominator? What's the derivative of 1 over x times x squared times arctine x squared of right? So what's the derivative of that?
I have,
Mhm.
can I answer? I have, okay, so basically, this is the numerator part, ne?
Okay, let me
My-
just wait. Let me write it down on my paper and then I'll just transcribe it. Okay, go ahead.
My numerator is negative, close open bracket,
Mm-hmm.
2x,
Mm-hmm.
arctan x squared,
Mm-hmm.
plus, open
Mm-hmm.
another bracket, 4x over 1 plus x to the 4, close bracket, close bracket.
Sorry, 4x over
4x cubed
4x cubed, okay, over
1 plus x to the 4, close
1
bracket,
plus x to the 4. Okay. Close
then
brackets, close brackets. Okay.
over,
And then
and
over.
then over, open bracket, x squared, arctan x squared, close bracket, to the power of 2.
Okay, right. So let me just write it down here so people can have a look. So basically you have the denominator here that is squared. So you have the denominator there that is squared. Right? And then the numerator. The numerator you have negative 2x arc 10 of x squared, right? Plus another bracket 4x cubed divided by 1 plus x to the 4, and then you close these brackets. Okay, so this is a very messy expression, but does everyone agree here? Just please confirm for the denominator. The derivative of 1 over x squared times arctine x squared. Okay, you really have to sort of like go through it yourself. And of course, you can use, since this is a quotient, you can use the quotient rule, which I believe is what she used here.
I do agree, sir, but I got 2x cubed instead of 4x cubed. Wow.
We got 2x cubed instead of 4x cubed. Okay.
Yeah, but
the rest is fine. In
yes,
this,
that's fine.
where'd you get the 2x cubed? Here. Oh, okay, right here.
Yes.
Okay. So But what about everyone else? So you had a 2 there. What about everyone else? You guys agree? Disagree?
So I have 4 because I think the guy who just answered forgot to differentiate the function inside arctan,
The function inside arctan,
which is x squared.
which is x squared. Okay. All right. But yes. Okay. So I think I understand what you mean. Okay. I want us to like go through it so we can. So let's do it as an aside. We are trying to find, because there should be a 2 here, by the way. Making a mistake when you're calculating, but it should be a 2. And we'll just discuss why. Okay, so let's copy this. Let me just. Okay, so let me just. So basically, we are trying to find the derivative of 1 over x squared multiplied by arctan x squared, right? So we should all follow here so we can move on. So using the product rule, sorry, we're using the quotient rule. What you have is you take the derivative of the numerator, you multiply it by the denominator. So when you take the derivative of 1, you get 0. Okay, when you multiply it by whatever the denominator is, you just get 0 as well. And then minus, that is minus the numerator, which is 1, right? Multiplied by the derivative of the denominator. Okay, so multiplied by x squared times arctan x squared, right? And then all of this is divided by the denominator, which is x squared times arctan x squared, all squared. Okay, so now let's find, let me just put the sign of differentiation there. Let's find the derivative of x squared times arctan x squared. Okay, so this is equal to, we can take out the negative sign for now, right? What do we have in the brackets? Here we have the product of 2 functions, so we use the product rule. So you take the derivative of the first product, which is x squared. So you have 2x. Okay, sorry. Wrong place. You have 2x, right? Multiplied by the second function, which is arctan x squared, right? Plus the first function, which is x squared, multiplied by the derivative of the second function. Now the derivative of arctan of x, right? Or arctan of any function of f of x. Let me just write it down as a rule, so it makes sense. When you're looking for the derivative of arctan of some function f of x, this function can be anything, okay? When you're looking at derivative of this, what you do is you take the derivative of, or you can go from outside. First, the derivative of arctan, you can use the chain rule. The derivative of arctan is always 1 over, right? 1 plus whatever the function is, right, squared. Okay, so let's square this, right? And then you go inside chain rule again, multiplied by the derivative of the function that is inside, which is f of x. Okay, that's the rule. But now when you apply it to our case here, we have arctan of x squared. When you take the derivative, you'll just write it back as 1 over 1 plus x squared squared, which is x to the 4, right? Which is what we had previously. But now multiplied by the, oh, sorry, I forgot, f prime. Multiplied by the derivative of f of x, which is the inside function. So the derivative of x squared, which is 2x, right? So that is what the numerator is equal to, and then the denominator just stays as x squared times arc 10 of x squared all squared, right? So now when you multiply in the numerator, what you get is the negative is still there, but now you get 2x arc 10 of x squared, right? Plus 2x cubed, right? Divided by 1 plus x to the 4, right? All divided by x squared times arc 10 of x squared all squared. Okay, so, and that is what we had here. So does that make sense for everyone?
Yes, it does.
Okay, so you can go through the calculations again. So if you're not sure, so you can understand it. Right, so this is what we have. Now, here we can sort of already simplify the expression in such a way that, let's see if we can simplify this further. Okay, but it's a very big expression, so the way we would simplify this by let me just recopy this entire thing. It's a very big thing, but okay, so let's first simplify the expression in the numerator. So in the numerator, you would now have, when you divide these two, you would have minus 2 divided by x cubed multiplied into 1 plus 1 over x squared, right? And then in the denominator, if you separated these two functions, right, because there's an addition there. So if you separated them, what you would get is, right, under the first negative, it should be negative, right? The 2x divided by x squared is just 2 over x. And the arctan x squared also, oh sorry, it's not x squared, it's x to the 4, right? Because it's squared here. So 2x divided by x to the 4 is just 2 over x cubed, right? 2 over x cubed. multiplied by arctan. When you divide the arctan x squared divided by arctan x squared all squared, you just left with an arctan x squared in the denominator. Okay, sorry, just so you left with an arctan x squared in the denominator there, plus now plus the 2x cubed divided by the 1 plus x to the 4, but in the denominator here, you're multiplying by x squared, so x squared squared, which is x to the 4, that can be simplified with the x cubed that is next to 2 here, so we can erase this x cubed there, because we'll simplify it. So it can be simplified by that x cubed there, and you just left with x here, multiplied by arctan x squared, which is squared. Let me just square this. As you can see, it's quite a long process. Right? So, and then there's another bracket there. So obviously now when you substitute in in the expression of sorry, when you substitute in the value of x as it tends to infinity, right? You should be able to simplify this entire thing, which is what I'll leave to you guys, because if we do it, we'll spend way too much time and we're running out of time here. So you should simplify further here in such a way that you get the answer, which should be e to the pi over 2, right? Or let me just double check. It's e to the minus pi over 2. Right. So, any questions here? Okay. Right. So moving on. But I believe there must be an easier way to do this. Okay, so because this process is very long, okay? So I think at this point here, you should be already able to use the expression, right? Because so that's what I want you to do, guys. So I want you to continue with whatever we've done here and see if you get to the final answer. But I also want you to try this. So alternatively, try using, right? So try using the expression. Let me just write it down here. Try using the expression that tells you when you have the limit as x tends to infinity of 1 plus 1 over x, right? Multiplied by sorry, to the exponent of x, that is equal to e, right? I'm not sure if you guys remember this expression. So there is this identity that is already given to you, which I suspect that's what they want you to use here, okay? So I think you go from this, right? But you just adapt it to your question, right? So in your question here, you have that okay, so you have that but basically you can generalize this expression, right? So 1 plus limit as x tends to infinity of 1 plus 1 over some function f of x to the exponent of f of x, right? E is equal to e, right? So if you apply it to our case, yeah, which is the fact that we have 1, the limit as x tends to infinity of 1 plus 1 over x squared to the exponent of x squared, right? That is equal to e as well, okay? So if you know this, then when you substitute in the into our limit, so when you bring in the limits now, right, you can just put to the exponents, right, on both sides of this expression. I'm not sure if you guys are following, but just look what I'm writing. So on both sides of this expression, you can put the fact that, so this is equal to e. But on both sides of this expression, you can put the fact that you can bring that to the exponent of arctan x squared, right? Same on the right-hand side. You have arctan x squared, okay? So basically, limits, right? So you have this limits there as x tends to infinity, right? So for this, you also, for e to the arctan x squared, you also have that x tends to infinity. So when you have e to the arctan of infinity, remember that that is equal to pi over 2. So your final answer should be equal to e to the pi over 2. So I think that I suspect that this is what they were expecting you guys to use this method. So what we are trying to do is basically go the long way, okay, which will still get you to the answer. And maybe you can do it as practice on your own time, but it should get you to the same final answer. Okay. So you can use this method again to get to the final answer, which should be e to the pi over 2. Okay. So I want you to attempt this other way here. Just keep going, keep simplifying, because as I can see, you might have to like use L'Hopital's rule again, but you try to simplify the expression as much as you can first, and then use L'Hopital's rule and see if you get to the same final answer, because I feel like you have to do this multiple times again to get to an answer, which is an exam or a test setting. You don't have that luxury, okay? So you need to like sort of move really quickly. Well, anyways, yeah, so try that and see what you get. Any questions? Yeah.
So how is a arctan x? E raised to arctan x squared equals to e raised to pi over
What
2.
as x? Sorry, I forgot to put. So basically, if you want, this is as x tends to Remember, x is tending to infinity, right? So this is as x tends to infinity. Because remember, you know that arctan of infinity is equal to pi of positive infinity is equal to pi over 2. Right?
Yes.
Yes. So as you substitute in the value of x here, so you have e to the arctan of infinity squared. Infinity squared is just infinity, right? So you have e to the arctan of infinity, which is equal to pi over 2. So you have e to the pi over 2, right? Not sure if it makes more sense there.
Makes sense.
Yeah, so you can try maybe as practice when you're playing around, keep going here and see if you get to a final answer. It's a little bit longer, but yeah. I see it. Yes, go ahead.
The answer is e raised to positive pi over 2.
Positive pi over 2.
Oh,
Yes.
but the choices we were given, it says the answer is e raised to negative pi over 2.
Okay, so wait, just give me a minute. Oh, I think I know what's going on here. So we made a mistake when when I was copying the question, I didn't realize that it's 1 minus 1 over x squared. Okay, so that's why it's negative pi over 2, because you know what they did. Okay, so let's just thank you for pointing that out. It's very important to notice this. So what they did was, if we have this expression instead, okay, usually the way you would solve this, right, because you're trying to get it to this point, because you know the limit as x tends to infinity of 1 plus 1 over f of x all to the f of x has already been proven to be equal to e to e, right? So what you're trying to do is manipulate this expression that is given to you so that you can apply this identity here. So what they did is they just rewrote this, okay? You can rewrite this expression as limit as x tends to infinity of 1 plus 1 over x squared over minus x squared, sorry, which is basically the same as that, okay? And then you multiply by -1 and you divide by -1 in the numerator, in the exponent. So you put minus there, but then you also add some brackets. Okay, so you add some brackets, and outside those brackets you put another -1. So it can cancel with this -1 that you have here. Does that make sense?
Yes.
So now when you bring the limits into the brackets, right? Because you can bring the limits into the brackets, remember? When you bring this limits into the brackets here, what you basically get now is you can say that that limit is equal to e, but now outside e you have e to the -1, okay? Because this is so this here inside, what's inside the bracket here, this limit is equal to e, but that's to the exponent of -1. Okay, so now what we have on outside those brackets, we have minus arctan of x. Sorry, go ahead.
What did you place to the exponent -1?
No, it's not to the, well, yes, it's to exponent -1 because you need to multiply by the minus x squared here to get x squared.
Oh, wait. Okay. Okay, I
Yeah,
see.
so that's why. Okay, so when you evaluate now the limits of the inside expression here, you get e, the e that we have from the identity here inside. But on the outside, you have e to the -1, right? That's for this specific case. But now if you had x, as this is the case for our problem, if you had x squared multiplied by x by arctine x squared, right? What you do now is outside here, you have -1 multiplied by the arctan x squared. Okay, so you have basically minus arctan x squared. Okay, so your final answer will be now minus e to the minus arctan x squared, right? But this is as, remember, as x, right? So as x tends to infinity, right? Positive infinity. So as x tends to infinity, that will give you now e to the minus pi over 2, which is the answer that was obtained there. Does everyone understand that?
Yes, yes.
Okay. So it's all about manipulations. You need to like sort of manipulate these expressions. Sorry, I forgot the minus there. You need to manipulate these expressions to make it easy enough for you to apply certain identities that you guys know already. So any questions? Any more questions on this? Okay. Yeah. So moving on, let's look at this question here, which I think will have to be our. Okay, no. I think this is a pretty straightforward one. So I think we should look at a more difficult one, or that looks difficult, which is question 6 here. Oh, no, sorry. There's so many good questions to look at. So let's say, okay, just which question do you guys want to look at? I feel like we should look at question 8 because it might be the most difficult of the ones here. Question 8. Or question 6 or question 3 as our last question, and then you guys can do the rest.
Yes.
Which one do you want?
Out of the 3 just mentioned.
So question, yes, of the 3 just mentioned.
Question
Number 8 and the other one.
Which one looks a bit more challenging?
Question
Number
8.
Question 8, right? Yeah, so I think that's what we should do.
Mentioned?
I can just give you some hints for all the other ones, okay?
Yes. Okay.
Oh, yes,
So
yes.
let's do question 3 first. For question 3, you have k is a positive integer, and you have the limit as x tends to infinity of x to the k divided by e to the x. Now, if you substitute the value of x, you will see that you have infinity over infinity, right? So you can apply L'Hopital's rule. But the problem when you apply L'Hopital's rule here is you will keep getting, right, infinity over infinity, no matter how many times you apply L'Hopital's rule. So that's the specific case for this function. So now what you have to use is the fact that if you sketch the function x to the k and the function e to the x, right? K can be any positive integer, right? As they told you. You will see that as x is going to higher and higher values, x to the k is getting bigger and bigger, but at a slower rate than e to the x is getting bigger. I'll repeat that again. So if you sketch x to the k and e to the x, and you change the values of x, use like put higher and higher values of x, you will see that x to the k is increasing, right, at a certain rate, but e to the x is increasing at a faster rate than x to the than x to the k. So for a specific value of x, you will see that x to the k will be lower than e to the x. So basically you will be, as x gets to higher and higher values, you'll be dividing a low number by a very large number. And what happens when you divide a small number by a very large number when you're looking at limits? What happens? What is that equal to?
0.
0. So your limit should be equal to 0, which is one of the options here, option E. Okay, so that's for question 3. For question 6, now you have the limit as x tends to 1, right, of f of x minus f of 1 over x squared x minus 1, which is, they're telling you that is equal to 3. And then they're asking you to evaluate this other limit here. So now, for this first limit here, if you substitute the value of f of 1, you have f of 1 minus f of 1, which is 0, over 1 minus 1, which is 0. And what happens when you have 0 over 0 for a limit? What do?
L'Hopital's.
L'Hopital's rule, exactly. So you apply L'Hopital's rule for this case. When you apply L'Hopital's rule, since f of 1 is a constant, it goes away. So now in the numerator, you have f prime of x divided by the derivative of the denominator, which is just 1. So you have f prime of x over 1, which is f prime of x. And f prime of x, when you substitute the value of 1 now, so f prime of 1 should be equal to 3, the 3 that they gave you here, right? Because remember, they've already told you that this limit is equal to 3 when you solve it. So f prime of 1 is equal to 3. So now when you apply it to this other problem here.
Hold on.
Sorry?
Why did you say f prime of 1 is equal to 3?
Okay, let's write that down. Okay, so I guess we'll have to do this one. I will be doing it quickly. So we already given by the problem that the limit as x tends to 1 of f of x minus f of 1 over x minus 1 is equal to 3. So we know this will be equal to 3. But let's first try to solve it. So if you substitute, you will get 0 over 0, okay? Which means you can use, which means here you can apply L'Hopital's rule. Okay, so when you apply L'Hopital's rule, right, you have to derive the numerator and derive the denominator separately, right? So let's derive the numerator here for our case. What do you get when you derive the numerator? Since f of 1 is a constant, it goes away, and you're left with the derivative of f of x, which is f prime of x. In the denominator, you have the derivative of x minus 1, right? Which is just 1. Okay?
Yeah.
And this will give you, as you substitute the value of 1, it will just give you f prime of 1 divided by 1, which is just f prime of 1. And that, according to the problem that we are given, should be equal to 3, right?
Okay.
Yeah, so now you know that. So now you can apply it to this problem here, the second part. So the second part now, again, if we're trying to solve it using L'Hopital's rule, when you substitute in the value of h, you have f of 1 minus f of 1 over 0. F of 1 minus f of 1 is 0, right? Divided by 0, so you have 0 over 0, which means you can apply L'Hopital's rule, okay? So if you take this and you apply L'Hopital's rule to this problem, again, f of 1 is a constant, so it goes away, and you're left with the derivative of f of 1 plus h, right? And in the denominator, you have the derivative of h in terms of h, which is just 1,
Yeah.
right? And you have that is just equal to, now, as you substitute the value of h, it's just equal to f prime of 1 plus 0, which is f prime of 1,
Sure.
which you already found that was equal to 3.
Yeah.
Okay, so this is equal to 3. So the answer should be 3. Okay, does that make sense for everyone?
Yes, it does. Thank you.
Okay, So moving on to question 8. Now you are given, right? So this question was about a bit tricky, but you had to use the chain rule. Okay. So we'll go through it slowly so everyone can follow, right? So what are you trying to find here? So let's just erase all of this. So you're trying to find the derivative, right? Okay, so let me erase this as well. So you're trying to find the second derivative of f of x cubed, right? Well, you're given that the derivative of f of x is just equal to some function g of x, and the derivative of that function g of x is equal to x squared. So now the second derivative of x cubed is just equal to the derivative of the first derivative, right? So it's the derivative of the derivative of f of x of cubed, right? Okay, so but based on the based on the what is it called, the chain rule that you guys have learned, you have to take the derivative of the outside function first, right? So the derivative of f of x cubed, let me just write that down like this. So you take the derivative of that first function there, and then you take the derivative of the inside function, which is the derivative of x cubed, which is just 3x squared, right? And then, right, you have to remember that you were given that the derivative of the function f of x is equal to the derivative of g of x, meaning that the derivative of f of x cubed will just be equal then.
Wouldn't you
Yeah.
first have, because you'd start with the, using the chain rule, you start with the outer function, obviously. Yes, but then wouldn't you also have, so now you'd have d over d of x, open bracket, d over d of x with that function, close bracket. Wouldn't you also have, now looking at the derivative of that inner function?
Yeah,
wait,
where
looking
is
at
it?
the
Which
thing,
step?
don't you have three functions, like the outer function, and then we have
Yeah, but we
inner
leave
function.
this. So we're leaving this derivative first. Okay, this one out here.
Yeah, I'm aware of that.
Yeah. Okay. So you're looking at the inside. Which step are you talking about? This one. This step here, or the
No,
next
the
one?
last one. The
The
last
last
one
one.
we just did, yeah.
This one here.
No, sorry, the second one.
Oh, this one here.
Yeah.
Yes.
Wouldn't you also have f prime x cubed times 3x squared?
F prime. Yes, that's what I said. That's what I wrote. So this d over dx of f of f. You can also write it if you want. Okay, as f prime of x cubed. Right? So maybe
Okay,
let me just write it down like that so it makes more sense.
Thanks,
If you do it like this, okay, let me just write it down there as well. So if you do it like that, but now remember, so the reason why I didn't want to write it down like this, because I needed to, like, I wanted you guys to see from what you're given here, how we will apply it here. But you can also say, you can just also write it down like this, as long as you guys understand that this f prime of x cubed is just d over dx of f of x cubed.
Yeah.
So just understand that. Okay. So yeah, you can write it like this. And then, but remember that you're given that d over dx of f of x is just equal to g of x. So you can substitute the f prime of x cubed by g of x cubed, right? I hope this makes sense. Because you're given that d over dx of f of x is equal to g of x. So if you had, instead of x, if you had x cubed, this would be equivalent as well. Right? Because composite functions, this is basically using like some version of composite functions, because you're just substituting wherever in those functions. Yes. Wherever you have x, you're just substituting by x cubed. So whatever applies to the derivative of f of x will apply to g of x, and similarly whatever applies to the derivative of f of x cubed will apply to x cubed, right? So you can make this substitution here.
I see.
So now, when you get the substitution, now you have the product of two functions, right? G of x cubed multiplied by 3x squared, and you're trying to find the derivative of that. So now you can use the product rule.
Yeah.
So you find the derivative of 3x squared, which is just equal to 6x, right? Yeah. Multiplied by g of x cubed, right? Multiplied by, plus the derivative of g of x cubed, which I'll just write as g prime of x cubed, right? Multiplied by 3x squared. Right? But now remember that, as you said, the derivative of g of x is just f of x squared. So if you had the derivative of x cubed, it's just f of x cubed squared, which is f of x to the 6, right? And let me just write it down so it makes more sense. F of x cubed squared.
Jonathan,
Yeah.
wouldn't you have, I agree with that 6x g of x here plus g prime x cubed times 3x squared times 3x squared again. Wouldn't you have?
Sorry, just give me a minute. Go ahead. Say that again.
For that second step.
Yeah,
so you
this
have
one here.
Yeah, that one. G. Okay, I'm good with the 6x, but that second one plus g prime of x cubed times 3x squared. Wouldn't you also have 3x squared again?
Okay, yes, that's true. Thank you for reminding me. You have 3 because you're doing the chain rule again. The outside function, right, multiplied by the derivative of what's inside. So you have a 3x squared that multiplies again out here. Right, so thank you for that. Yes. And then, of course, you would see that you're given that d of a dx of g of x is just equal to f squared. So when you substitute the x by x cubed, d over dx of g of x cubed is just equal to f of x cubed squared, which is x to the 6. So let me just write it back here. Right, so now you have, so this is equal to, let me just recopy this. And then you would have this part here is equal to f of x to the 6 multiplied now by 9x to the 4, right? And that is it.
Yeah.
Yeah. So I saw that in your test, one of the options that was given was so there was a mistake, I think. One of the options that was given was, let me just find it. Yes, it was 9x to the 4 f of x to the 6 plus 6x g of x squared. I think it was meant to be g of x cubed there. But it's the correct, that's the correct option, okay? So you can only choose what's given to you there. So that's the correct option. So this is the final answer that you should get. Is there any questions here?
I'm sorry, sir. That's f of x raised to 6 is coming from f of x cubed squared.
Yes.
Yes.
3 times 2, 6, yeah. Any other questions? Okay, if there's no other questions, I will end it here. So what you have to do is basically finish up with question, which question was it again? Oh, I think we did all of them. No. Well, yes, you really have to like write down question 3 now and do it properly. And yeah, attempt all the other ones. And if you have any questions, any queries, you can always contact me. Right. Thank you for attending. I'll just
Jonathan.